Hello everybody, I hope you're well. Another weekend, another day booked for some gas and electrical testing. So I've got my tools ready for the testing. For gas, I have an Anton Sprint Pro 3 gas flue analyzer. For electric, in this box we have a Mega 1741 Plus, all calibrated, all in date, and the rest of the gear to go with it, all the cables and everything else that I need. My trusted Vera screwdriver and ratchet set with side cutters in it. This baby that no one should be without. Amazing for at least opening all the sockets and stuff like that you need. It's got an interchangeable head, so flat head as well as a Phillip head there, and another Nipex plier. Then I have my Stanley Fatmax bag with all the gas gear in it, as well as a Vera tool pack, and that is another thing that I use quite often. So yeah, all of the tools are ready for testing, and not forgetting my notepad and pen to write all the results. Now, the property layout, as soon as you enter into the property from the main door, so that's the garden outside, so you enter into the property, you walk into this hallway area, and we have a small cupboard right in front of us, and this is where we have the electrical supply coming in and the consumer unit, as you can see. So we're here, this property will be rented. So the customer, they purchased the property recently, and they want it checked as they're going to be renting it out in the near future. So we have supply coming in, meter and consumer unit. Not many agree to having a plastic consumer unit in this day and age, and it's always a recommendation providing it fulfills all the rest of the categories, requirements I should say. This was tested back in December 21, and recommendation was to check it again in 26. But customers not received any paperwork from the previous owner, so they have to have it tested again. So I'll be going through all of that today. There aren't many circuits in it, starting from the main switch. There's unidentified, unmarked circuit there. Then we have a lighting socket in bedroom on a 16B16 breaker. Some more sockets in a bedroom, kitchen sockets, and then one RCD protecting these. An RCD as well, as you can see, it's a type AC RCD. So that's another recommendation, providing it actually trips within the specified time under load conditions. So that will be all the testing. Another thing we noticed whilst carrying out visual checks is majority of the fittings in the property all seem to be class 1 fittings. So we must have a CPC present in all of the circuits, lighting circuits I should say. That again could do with putting it back together also. In the lounge we have multiple sockets, so 2 I can spot there, third one there for the heater. That's a 4th double socket, 5th, so quite a few sockets in this room. And then from the living area, we have a staircase going up. And also, we walk into the kitchen around the back. So this is the kitchen. Here we have one gas appliance, so we'll be carrying out a gas safety check as well today. Again, same scenario with the lighting. Class 1s most likely, but when we open them up to have a look inside, it'll confirm that. Under sink, typical setup, we have the main stop tap, and I can see a bonding conductor connected to it. Also, gas pipework is coming in just there. So I can see that it's sleeved, and I can also see that we have earth cable connected, the bonding cable connected to it as soon as it comes in. Now, it seems like bonding cable is coming from the top, and then it's connected to a couple of locations on the gas pipe, and then it's going to the water. So one of the requirements is that if we are looping it, it has to be a continuous cable, we can't have it cut in these connectors, if it makes sense. So as you can see, there's a loop there, and I'm expecting another loop here as well. Otherwise I'm going to have to put a connection, a permanent connection on the cable and connect it that way. So that's that. The gas meter is down the back outside. So that's where the gas meter box is. So this is where the gas meter sits. Now internally we have an understair area for storage, but we don't have any lights or sockets in here that I can see at least. Okay, let me take you upstairs now. Before we go upstairs though, one thing I've noticed is smoke detectors. Again, in rented accommodation, it's a requirement to have mains wired, battery backup, interlinked smoke alarms. In this property, we don't have any mains powered smoke alarms. There were some battery operated smoke alarms here and there, but no mains powered. So that's something we have to sort out. Upstairs in the hallway, a socket in here. We have 3 bedrooms. So this bedroom towards the back of the property, another bedroom towards the front, and then another box room just through there. And then we have a spacious loft space, and this is where a Worcester boiler is installed. So we'll get up there to test this boiler as well. And again, all the lighting in the property seems to be all metallic fittings, so most likely class 1s. So we'll be checking that, and we need to ensure that we have earth. In the bathroom we have some spotlights and typical bathroom setup. In this bedroom again, we have 1 light in the middle, 2 sockets per bedroom, 1 and second double socket there, and 1 light point. Ideally they could do with 3 in each bedroom if possible, but that's what it is right now. So a double socket here and a double socket there. Same again, light point. This must have been an airing cupboard for possibly a boiler at one stage, because I can see, not boiler, I should say water cylinder. There were some pipe holes that I've spotted earlier up there as well, as you can see, and they must have carried out a combi conversion, because it's just a combi boiler up there now. Or I could be wrong, they may have not put a cylinder in here, but either way we have a combi boiler to deal with. So I'm going to go downstairs now. I'll make a start with gas first, because that's one easy, and second, it doesn't, once I've turned electrics off, I won't be able to do it up until electrics comes back on. So I'll do gas first. So on the cooker, on the gas hob, is visual inspection, gas rating, making sure if it's got any safety devices are working perfectly fine. So let's have a quick look. Do we have any safety devices on this? Yes, so we have FSD, as you can see. So we need to make sure it does cut out when there's no flame, and also do all the rest of the checks. And then we'll be moving on to the boiler upstairs. We do have an openable window and a door to outside, so it fulfills all the ventilation requirements. We'll be carrying out a tightness test. Again, that's not a necessity as part of your gas safety checks, but I always do. Majority of the landlords, they do ask for it as well. So I will do that. I've spotted that there is an electric outlet feeding this cooker hood, so we'll be testing that also. But yeah, I'll make a start and we'll take it from there. Okay, so ready for the gas tightness test first. This is what the meter looks like. Now before we touch the ECV handle or the meter, we need to ensure that it's not live. So we'll use a non-contact volt stick that I've just proved to make sure it works, and we just want to make sure that the system is not live, or the installation is not live, before we touch it. Okay, and then we need to reprove to make sure the volt stick still in working order. Yep, so that proves it. So now we are safe to touch the installation. I'll be using my Anton Sprint Pro 3 for the test. It's set to test menu. My 10mm nut spinner. Let's turn the ECB off. Unscrew the test point. Put tube on it. And the first pressure we need is between 7 to 10 millibar. So on this tube here, we have a little point where we can release some gas, so we don't have to remove tube to release some more and put it back on. So that's dropped it down to 11.6. Let's release a bit more. Okay, let's see. Do we have enough now? That's fine. So what we're going to do is we're just going to start this test. So that's our initial let-by test. And here we're looking for an increase, ensuring that there's no gas passing from the ECB when it's in off position. Providing we have no increase, we will then increase the pressure to between 20 and 21 millibar, let it stabilize for a minute, and then carry out an actual tightness test for 2 minutes, making sure there's no drop on this installation. And if there is, it needs to be within permissible limits with no smell of gas. So we'll do that. I'll fast forward that and I'll see you as soon as the test's finished. Okay, so test is nearly complete now. In the last 10 seconds, as you can see from the pressures, there's no drop whatsoever. So 2 minutes, we stop the test. Yes, it's a pass. Let's save that on today's date, so then we can transfer that data for our test, and then we come back to the test pressures. We escape it because we don't need tightness test anymore. Let's go to pressures. In fact, we can carry out, rather than just pressure, working pressure. So we click that, we open up the ECB, we go inside, we turn the hob on and get the working pressure for the hob, and then we will take it from there. Let's go see inside. Okay, so I'm leaving the door open, and let's just see. Large burner, medium burner, medium burner. Nice blue flame on it. Let's just make sure that when we put it on simmer, it doesn't go off. We need to do the same with the small burners as well. Yep, so it's staying lit. That's fine. So 3 burners on full. Let's just make sure that our working pressure for the hob is fine. 19.56. So it's a bit on the low end, because when we turn the boiler on it may drop further, but just for the hob it's perfectly fine. As far as it's within limits, 21 plus or minus 2, so it can go to 23 or it can drop down to 19. We're happy with that. So that's what we've got. Let's just observe it for about 5 seconds so we can create a log which can then go towards our paperwork. Okay, happy with that. And then we can save that. And come out of that. Okay, that's perfect. What we're going to do next is we will check the inlet pressure at the hob itself. So let me just turn these burners off. We'll allow it to cool down, but we also want to make sure that we hear the clicks. One, 2, 3. So 3 burners. So if we turn the gas on now, there's no gas coming out up until we press and hold it. So as you can see, so we have to press and hold it for it to work. So all three burners are perfectly fine. I'm going to be bringing the gauge in, so I need these burners to cool down so I can check the inlet pressure as well, and then we will gas rate it. Okay, so I suspected the working pressure at the meter to be a bit low, so I've turned both appliances on. As you can see, hob, 3 large burners, hot water's running on full rate, so the boiler's fired up. These are the only 2 appliances in the property on gas, so let's just ensure that we don't have insufficient gas going to the appliances. And as you can see, on full demand we have 19.33 millibar, so we have plenty of pressure going to both of these appliances. So let's turn them off. Okay, I've already gas rated the hob. I found a manual for it, and this provided us the information required for gas rating. Combined, all 4 of these burners come to 8.3 kilowatt. Sometimes you may not find a manual on site, and you may have to remove a drawer from underneath it to get to the label data badge, which is on the underside of this hob. And occasionally we have ovens mounted, so sometimes we have to pull an oven out to get to it as well. But let's see where it gives us that information in the manual. Okay, so we have information required here on natural gas. As you can see, G20 maximum output. So we have 1 small burner, which is that one there. We have 2 medium and 1 large burner. So 1 small, 2 times 1.75, and then triple flame burner 3.80 combined is 8.3 kilowatt, which gas rate was perfectly fine. It was around 8.24, so it's working perfectly fine there. Now that this is done, I'm going to be moving on to the boiler next. All the checks are completed on here. Safety devices checked, inlet pressure checked, visual inspection all checked, and gas rate is perfectly fine as well. So we're all good with that, and I'll be going upstairs to check the boiler next. Okay, so I'm up in the loft at boiler location now. As you can see, boiler's mounted on the external wall, but we have a vertical flue going up and coming out of the roof. I had a look when I was coming into the property, and terminal looks perfectly fine. It's got flue clamps, so we've got 2 flue clamps holding it, and it's nice and solid. As you can see, it's not going anywhere. It's got the correct flue adapter. That's going to give us combustion analysis reading on the left and the flue integrity on the right. But before we do all of that, we need to know what we're checking it against. So we have a GC number there, and what we're going to do is we're going to put this GC number into our app, and that will tell us all the information about this boiler. So let's do that next. So I've opened up the Gas Fault app, and let's type in the GC number for the boiler, which is 4740660, and that brings up the correct boiler. So we click on it, and we need service information. So when we click on that, it gives us all the information that we need for gas flue analysis, for gas rating, when we check in the fan pressure. So as you can see, when we gas rate it on maximum rate, is 25.51 kilowatt net. The CO percent on maximum rate, it needs to be between 9.0 and 10.8. On minimum rate, CO percent needs to be between 8 and 10.6. We need to ensure that it's at least 0.2 lower than the maximum CO2 reading. The maximum ratio we can have on this boiler is 0.002, so it's not 0.004. It's actually specified as 0.002. Maximum CO parts per million is 200. Fan pressure, when it's on full rate and when we check it, it needs to be in negative, and it needs to be greater than 4.5. So if it's below that, then it warrants a full strip down service. Minimum gas inlet pressure, whilst we are carrying out a test on full rate, needs to be at least 16.5 millibar. So we need all that information that we need to carry out all the testing that we need on this app. Now, if you didn't know how to put this boiler in service mode, or any boiler in service mode, for example, it does give you that service mode option. So when you click on it, it tells you how to put this boiler, or the boiler you're working on, in service mode in low and high reading. Now, obviously, we need to also check the flue integrity as part of our gas safety checks. So whilst it's in full rate, we need to ensure that we have at least 20.6% oxygen coming to it, and the CO2 is less than 0.2%. So 0.2% or less than that is what the CO2 reading needs to be. So let's just put the boiler in service mode in high and low rate and get some readings. Okay, so I've isolated the boiler from the fuse spur and just carrying out a quick visual. So I've removed the front cover and dropped this front lid down. Just carrying out a quick visual first to ensure we don't have any water leaks or any damages that we can spot. Everything seems to be all good in this section. In the top section, everything seems to be all okay as well. It's all good. So when we're doing the testing, that white cap is what we're going to use for our fan pressure test. On the gas valve, it's a non-adjustable gas valve, by the way, so we don't need to adjust it. If it's out of the limits, then it's a new valve job basically. Or we need to make, obviously after checking all the gas and everything, to make sure we don't have any other contributory factors, but otherwise it will be a new gas valve if it's outside of tolerance. But the bottom test point is what we're going to use for our inlet as well, inlet pressure. But everything else seems to be all okay within the boiler. And now we're going to turn the boiler on, put it in service mode, and we will get some readings. Okay, so our gas flue analyzer is ready. I've connected it to the inlet point of the gas valve, as you can see. Sorry, it's a bit dark in here. Flue analyzer's been zeroed, and the standing gas pressure is 24.94, whilst the oxygen level is 20.9. But it's not giving us any other reading because the boiler is not in service mode right now and the probe is out, as you can see. So what we're going to do is, I'm just going to put the boiler in service mode first of all. So for this one, you've got to press and hold this chimney sweep button. And as you can see, it puts in service mode. So initially it activates in max. To put in minimum, just press up or down, and it goes between minimum and maximum. Okay, so we'll leave it on maximum rate, and we will allow it to run for a few minutes. Heating's been on, must have cooled down in this time that we were doing the rest of the checks on hobs and stuff like that, but when I came in the heating was on. But we will just check it in a bit just to ensure it's not going to flood our analyzer. It's always good to just allow it to run for a little while. Okay, so, and the one on the left is the point for flue analysis. Let's put the flue analyzer in. Okay. So flue analyzer is in now. The boiler's on max rate, as you can see, and the readings stabilized on maximum rate. CO2% is 10.2, so that's well within limits. CO parts per million is 73, and ratio is fine as well, 0.0007. So we're all good there. What we're going to do is we're going to put in minimum setting next by just pressing up or down, and that puts in minimum setting. And in here we're expecting the reading, CO2% reading, to be at least 0.2 lower than the maximum we had. And it needs to be 8.0 to 10.6 really. So let's see. So as you can see, CO parts per million dropping down, CO2% is dropping down, and the ratio is also dropping down as well. We had the pressure, enough pressure in there as well, the gas pressure on full rate. obviously we needed to check the pressure on high rate, which we did, and I believe it was 18 point something. Must be in recording, because I didn't glance at that, but it was recorded. So there you have it, 9.7 on low rate with 15 parts per million and 0.0002. Let's just save that, and then we'll put it up in, we save that log, and let's put it up to high rate once more, because I forgot to save the log there. We do need that information if you're using the Anton's app to create certificates, because if you forgot to take logs or save logs on your phone or on the device, then it doesn't allow you to populate it. So populate it manually. So I hope that we have enough memory in my phone to keep recording, because it was giving me warning earlier, so I need to free some space. As you can see, on high rate, although it's still climbing, but we have 18.09 pressure, inlet pressure at the inlet point on the gas valve, which is more than 16.5 minimum that we need. So we're all okay there as well. I'm happy with that reading, so I will save that log as well as high rate. So that's perfect. What I'm going to do next is I'm going to carry out the flue integrity test to make sure we don't have any mix-up happening due to any of the seals, and then we will do the fan test as well. Let's just do that next. Okay, so I'll move the gauge onto the fan test point now. The boiler's in minimum rate because it's reached its temperature, but our flue analyzer is ready to measure the fan negative pressure now, and we need more than minus 4.5. So let's just put it in high rate, maximum, and let's just observe the pressure. Let's just record it as well. The boiler is going to high rate, and the fan pressure is also getting within limits. So 4.5 was the minimum pressure that we needed. We're more than happy with anything more than minus 4.5. So we're happy with that pressure on high rate, and we will just save that, because our boiler now is cutting out as it's reached its target temperature. So we have that pressure there as well for fan, and the last thing we're going to do is I'm just going to put the cover back on and carry out a flue integrity test, and then a sweep test around the appliance, and in particular around that seal, because on these, if these seals not being replaced on services, it does every now and then start to leak. Okay, so the boiler cover's back on now. I need to carry out flue integrity, but as you can see, the water pressure is a bit low as well. So let's just top up the pressure, and that will add some cold water into the system, and when we put it on high rate, it's going to hold it for a bit longer. Now to top it up, we have this setup here. So this key, as you can see, there is a lock and unlock section there. So if that key is in that unlock position, you can actually take this key out like that. A bit of water comes out, but we have a tub underneath it anyway. But to put this key back in, you push it back in, and then when we twist it clockwise to the lock position, that's when it allows the water to go into the system. So once it's in that locked position, what we need to do is we need to open this square anti-clockwise, and I can hear the water going into the system. Let's just top you up to around 1.5 bar. There we go. And then clockwise we nip it back up. Okay, so now we've topped up some water into the system. So what we're going to do is we'll just put the boiler back in service mode on high rate, so we can get our flue integrity as well. Whilst it was in high rate earlier, I was doing combustion analysis. I went down and checked the gas rate as well, so it's well within limits for gas rating. I did a quick sweep test around the flue seal and everything is perfectly fine. It's not leaking any combustion products into the chamber, so we're all good there as well. So now it's in maximum rate. Let's just put our flue analyzer here, gas flue analysis, and we're only looking for the oxygen reading and the CO2%. As far as we have above 20.6 on O2% and below 0.2% on CO2, we're good to go. So the boiler's fired up, as you can see. Gauge is connected in the O2 sampling point and you're perfectly fine there. So that's all good. Let's log that as well. So that's all sorted. The last thing to do now is a quick sweep test around the appliance sweep test, and that's 2 minutes test. I'm going to do that next, and then that's it. Gas safety check is all complete on this. We just need to ensure we have carbon monoxide alarms. We need to test them. Let's just take that out of the service mode. We don't have any smoke alarms in this property. We do have some battery operated, but those are not in working order. But I'll most likely be installing some smoke alarms anyway in this property. But I need to do electrical testing first to find out what else we need to do. And we'll take it from there. So that's the gas side complete, and we'll be moving on to the electric next as soon as I've done with the sweep test. Okay, so it's electric next now. What we're going to do is we'll just turn everything off to start with, but before we turn the main switch off, let's just make a start with circuit breakers, followed by RCD, and then the main switch. So that's all turned off. What we're going to do next is we're going to remove the cover, and let's have a quick peek inside of it to start with to see what we're up against. Okay, so that's the cover removed. At this stage we need to be careful because we haven't proved anything dead yet, so we don't know if by turning these things off it's definitely safe for us to continue. So we need to ensure that we prove dead and then we will carry on. Okay, so that's the next step. So what we're going to do is we will carefully remove this cover, and that will expose the connections at the bottom. And as you can see, that being the main switch, it's got a bus bar coming up to here and then it's cut off. Not very clever way of doing it. And then from the RCD we have 1, 2, 3, 4, 5 circuits being fed off RCD here, but I can see that there's nothing feeding this MCB, so at some stage somebody must have disconnected something out of that. So that's a spare, and then on this side we have a spare as well, which is this 32 amp breaker. But the very first thing we're going to do before we do anything else is we're going to prove dead to make sure then when we do the rest of the testing we are safe. We will be doing some live testing as well in a short while, but we need to ensure that we're not coming across or touching ended up touching these whilst we've not proved dead. So to achieve that, I'm going to be using my test lamps, my 𝐃𝐈𝐒𝐂𝐋𝐀 proving unit. I can prove these test lamps on the incoming supply as well, but I've got the proving unit, so I'm just going to prove these test lamps using my proving unit there. And as you can see, my test lamps are working perfectly fine. Then what we're going to do is we will go in the least dangerous conductor first, which is neutral in our case. So neutral to live, there's nothing there. Remove live first and then neutral. Neutral to earth bar at the top, we have nothing there, that's good. Earth to live, we have nothing there, that's good. And then we reprove our test lamps. We can reprove them in the proving unit or in the non-supply source, which is the incoming supply to the main switch. So that confirms that there's no power passing this main switch. And if it's not passing this main switch, technically it's not going to the other side to feed the RCD and the rest of the circuits as well. However, there's no harm in just checking this side as well, just to be on the safe side. Okay, so what we're going to do is we're going to go on neutral and the bus bar underneath. And if you wanted to be 100% sure, just check the load as well. There's no harm in doing that. It's only going to take you a minute or so extra. Then against the earth, we're going to be checking bus bar. And then if you just want to be 100%, you can check the circuits at the top as well. And then we reprove our unit again using a proven unit or the known supply source at the consumer unit, which is incoming supply, but that proves our test lamps are still working. So now we are safe to work downstream of this main fuse or main isolator. It's not a main fuse, it's a main isolator. So we can work on this section here. Okay, so we will have quick inspection now to see what's feeding what, and we will take it from there. Let's see what we're up against here. So as you can see, from the main isolator, the one on the left has no load on it, so that's spare. And the bus bar setting, as you can see, is like that. So if that's spare, I would be tempted to just remove this circuit completely. That will eliminate all of that, and it's a bit more safer. Then we have a B6 that's feeding lights. We have a B16 next to it that's feeding bedroom sockets above as per was pre-marked, if that's correct. The one next to it is a B20 that's also feeding some sockets in bedrooms. Then we have a B32. So as you can see, beside the lights one, these two are just radial circuits. That's on a B32 and it's marked as kitchen ring. So if that is a ring, then that's fine, it can remain on a B32, and the one next to it is a spare anyway. And as I mentioned at the beginning, we have a type AC RCD in here. So as far as it trips within the correct load, within the correct time, whilst it's under load, we're fine with that. Ideally, I would like it to be a type A RCD rather than be an AC, but it's an old consumer unit with a type A AC RCD in it. The consumer unit integrity, we don't have any holes at the top. And IP rating at the bottom is fine also, but I will be recommending a consumer unit upgrade on this installation, but obviously our EICR may reveal other stuff that we need to do to it. I can see 16mm main earthing cable going into the consumer unit, and I can also see two 10mm coming out, so I'm assuming one's going to gas and one's going to water, although we saw earlier that it was looped from one to another. I seemed as such anyway, so we will just double check that when we're going to be proving the continuity on both gas and electric pipes. So that will come to light in a short while. Okay, so the very first thing I'm going to do next is carry out a ZE test. For that, I need to remove the earth cable out of the earth bar, and that's the main earth going into the consumer unit, and check that against incoming light source, and we're going to get the external earth loop impedance. As soon as I've done that test, I will put that cable back in, and then we will move on to the PFC test. And then once we've done that, I will then be moving on to the continuity. So all the dead testing basically, continuity, polarity, insulation resistance, and then the ZS on each circuit. So yeah, I'll move on to that next. Okay, so as you can see, I've removed the main earthing conductor out of the earth bar, and now what we're going to do is we're going to test it for the external earth loop impedance. So my meter, I've got one crocodile and one pointy connector. I'm going to set it to the correct setting, which is on this meter is live to protective earth, and we don't want to put it on max, we just put it on Z on the second setting here. When you put it on that setting, it straight away takes you to 3 low. We don't want that. By pressing this button, we can change it to 2 high. So to carry out this test, we will keep it on 2 high. So what we're going to do is we will put the earth conductor first, nice and firm, on the main earth cable, and then the other point we will use live for it. And as soon as we do that, the meter will automatically carry out a test, and it's giving us a 0.12 ohms. Now, as I mentioned earlier, by just looking at the supply, incoming supply cutout, on this occasion, at least I can determine whether it's a TNS or TNCS. Now, this reading indicates that it's most likely a TNCS because the maximum reading for TNCS is 0.35 ohms and the maximum reading for a TNS system is 0.8 ohms. So that's a very low reading. So it's indicating that it's most likely a TNCS system. And that's what we'll be putting it down as. If there is another method of confirming that, it's a Sunday afternoon, so I can't really contact DNO as well to investigate. And to me, it doesn't really make much of a difference on this occasion because the reading is well within the limits for both, whether it was TNS or TNCS system. But if there was another method of confirming that, please do share with me in the comment section below. It's always good to learn new things. So what I'm going to do next is straight away I'm going to put this earthing conductor back in its terminal, and then we will proceed with the PFC test. Okay, so next test we are going to do is a PFC, so it's a prospective fault current. So we'll be carrying out 2 tests for this reason, and then highest of the 2 readings will become our PFC reading. So the first test we're going to do is live to earth. So that will be our PEFC, so that's a prospective earth fault current. And then we will get the reading, we'll make a note of that, and then we will carry out a PSCC, which is a prospective short circuit current, and that's between live and neutral. So let's set our meter back to the correct setting, which in this case is live to protective earth. Again, it's set to L3 LO or 3 low. The minute you turn this meter on, it automatically takes you to 3 low setting. By pressing this button here, you can change this to a 2 high. So that's what we need for this test as well. So let's just test it. I've got my crocodile clip connected to earth bar, as you can see, and we will put our next point on incoming live. So the meter will automatically carry out a test for us. And on this occasion, between live and earth, we have 1.87 kiloamps. Okay, so what we're going to do next is we will remove it from earth and we will check against live to neutral. Okay, so I'll try to perform the test with one hand. Let's see. So neutral first, then live. We don't need to change anything on the meter. And the highest of the 2 readings, which is in this case is 2.49 kiloamps between live to neutral. So this becomes our PFC. Okay, so our PFC is 2.49 kiloamps, and that's the reading I'm making a note of. Okay guys, so I've just finished with the rest of the testing. My phone battery decided to run out, so I've recharged it and I'm just doing the last RCD test. I had to shift a couple of circuits about. All the lighting are on one, they were on one already, but 2 bedrooms upstairs that were separated for some reason on 2 different breakers. So in one bedroom there were 2 sockets, and one was on one circuit and another one was on another. So I've combined that as well, but we're just going to do a quick RCD test. So times 5 I'm going to test here, and it's a 30 milliamp RCD. It's already set to a type AC RCD. So let's just do a quick test. We're going to put the crocodile on the earth side. So that's earth has a crocodile clip on it, and then the outgoing live should give us that. Let's just press the button. Okay, you heard the click, and 5.71 millisecond. So that's a pass, and as you can see, it was under load condition. So although it's a type AC RCD, it's functioning. So we will just class it as C3 and recommend it to the customer to have it upgraded. And that's the same with the consumer unit as well. I've also disconnected the bus bar, as you can see, from this circuit, because that's just spare. So it's just this side that's functioning. So literally 3 circuits, a kitchen ring, 2 radials for bedrooms and living room, and lighting circuit really. That's about it. So if you have any questions, feel free to drop me a line in the comment section below. Don't forget to like and subscribe to the channel, and I will see you in the next one. Take care. Bye for now.